In this video, I'm going to be covering question 5, part C from the 2019 AP Calculus AB free response, no calculator allowed portion of the test. If you want to see parts A and B, I cover each of these in their own individual videos, so go ahead and check out my other videos. So part C here, we actually need to know when they talk to us about this region R up above this graph, we need to know which of those equations is the top equation. So is g of x that top equation up there, or is h of x that top equation? We talked about this back in the video for A, but if you're just watching the video for C, you would have missed out on that. So real quick, to make sure we know what graph is up above, think about what your parent functions would look like is kind of the quickest way to do this. So a cosine graph normally oscillates up and down over and over again. And then we've got x minus 1 squared here. The parent function of that is x squared, which would normally look like a parabola. So from that, we can kind of see that h of x would be this top equation, and g of x would be the bottom equation. If you can't recognize that just from looking at those graphs, or you doubt that, your eyeballs, then what you have to do in that situation is you got to plug in a value here. And the easiest one to plug in would be x equals 0. Plugging 0 into g of x, you would have gotten out a y value of 1, which would have showed you that that would have been the dot on the graph there. Plugging 0 into h of x, you would have gotten out a y value of 4, and so that would have shown you that you have this dot right there. So again, if you can't just trust your eyeballs on the shape, you got to plug in a number. The easiest number to plug in is 0, and then see where the dot on the graph would be located. So then from there, now that we know what we're looking at the graph up above, let's see what this question is asking us to do. So they want us to write, but do not evaluate. I love that. That's always my favorite type of problem, when I don't actually have to do all the math to finish it out. An integral expression that gives the volume of the solid when r is rotated about the horizontal line y equals 6. So we are doing a volume of rotation problem, but we are not rotating around the x-axis. We are rotating around this y equals 6 line right here. We're going to be rotating everybody around that line right there. When you're rotating two equations together, this is when you're going to be applying the washer method. When you got one equation, you're going to be using the disk method. When you got two equations like we have here, we would be using the washer method for doing this. So the washer method says I take the integral from a to b of pi times, and then in parentheses, or usually they put a bracket, you would have big R of x squared, what they call the outer radius, minus little r of x squared, which you would call the inner radius dx. So this would be the outer radius, and then this piece here is going to be the inner radius. So when you come to do this, the easiest way to do this, to try to figure this stuff out, is to kind of draw yourself a little representation of what each one would be. So if I started at 6 and drew out to my first graph, whatever graph I run into first, that right there, that's going to create my inner radius, because that's the first thing I run into. And then I draw from that 6 down until I hit my second graph. And whatever I hit second, that's going to be where my outer radius comes in. And so now what I need out of there is I need two equations to represent the inner and the outer radius. Well, to find those, this really gets back to this idea of how do I find the gap between two equations. This is, if you go back to part A, that's how we found part A. To find that gap, the gap between two functions, you find that distance by taking the top minus the bottom in parentheses. So when I look at r of x right now and find that inner radius, y equals 6 is above in this region here. Y equals 6 would be my top, and then h of x would be my bottom because it's down below here. So to set up my inner radius, I would take my top equation, which is 6, and subtract off, always in parentheses, that full bottom equation, which would be the h of x equation right here. So this would be 6 minus 2x minus 1 squared, close it, and then you'd close the whole thing. So that would be my inner radius equation. Now to find my outer radius, I play the same game. I'm doing top minus bottom. Well, the top is still this function right here. It still would be 6. So I've got top minus, and now my bottom equation is going to be my g of x equation, because that's the one that's down here. And so g of x is given to us by this equation. So negative 2 plus 3 cosine of pi over 2x, close, close, and close one big old time. So again, what you're doing when you're doing these inner and outer radiuses is you're really doing a top minus bottom. And if you draw out a little representation of those radiuses, it's really kind of straightforward to see what happens. Now all we need to do is just put this thing back together because we don't even have to solve it. We just got to set it up. So working our way left to right through this thing. So A would be our lower bound. That's going to be the left side over here. That's x equals 0. So we have a lower bound of 0. Our upper bound is going to be this right-hand side over here. That's going to be an x value of 2. And then it'll be pi times this whole thing. And so from there, I come in and I need to take my outer radius squared. So this is my outer radius formula. And more than anything, this is just about tracking all these parentheses. So I've got one big set of parentheses because I got to square this whole thing. And then I've got the parentheses that were coming from this. So then from there, I would get 6 minus negative 2 plus 3 cosine of pi over 2x. Close it once, close it twice, close it the third time, and then I got this extra one now from squaring this whole thing. So all of that squared. I know, keep track of a lot of parentheses, right? Minus, and then I come over and do my inner radius. So again, I got a starting set of parentheses because this whole thing's going to be squared. And then I'm going to plug in my inner radius formula, which is going to be 6 minus 2, x minus 1 squared. Close it again from doing those two, and then I've got the full outside one that needs to be squared, and then I got my bracket at the end of this thing, and all of that dx. And you are psyched because you're done at that point. We just needed to set this thing up. We do not need to evaluate. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.